Welcome to the DIY Honda Garage channel. The error code P0130-99 relates to a significant issue within the air-fuel ratio, AF, sensor circuit in the 2023 Honda CR-V. This sensor, also referred to as Sensor 1, plays a critical role in determining the vehicle's air-fuel mixture by measuring the oxygen concentration in the exhaust gases. When the output voltage of Sensor 1 deviates significantly from standard oxygen levels during deceleration phases, the Powertrain Control Module, PCM, is triggered to recognize this anomaly, resulting in the code being stored. The primary function of this sensor is to help maintain optimal combustion efficiency, enhance fuel economy, and minimize emissions. Located typically in the exhaust system before the catalytic converter, the AF sensor's correct functionality is vital, not just for performance, but also for the overall environmental impact of the vehicle. This guide serves to inform on troubleshooting steps needed to resolve the issues surrounding this DTC. The error denoted by DTC P0130-99 indicates a malfunction in the air-fuel ratio sensor, specifically Sensor 1, which is critical for accurate engine management. This sensor measures the oxygen concentration in the exhaust system, which allows the Powertrain Control Module, or PCM, to adjust the fuel-to-air ratio for optimal combustion. If the sensor fails to report accurate values, particularly during deceleration, the PCM identifies this discrepancy and stores the DTC as a warning of potential performance or emissions issues. The location of the A-fuel sensor is typically before the catalytic converter in the exhaust system, making it essential for emission control strategies. Maintaining the sensor's functionality is crucial as it directly impacts performance, fuel economy, and emission regulations compliance. Any significant deviation in its output voltage indicates a performance problem that needs immediate addressing. Several factors may contribute to the generation of the DTC P0130-99, with the most prominent being a faulty air-fuel ratio sensor. If the sensor's internal components fail or degrade, they may no longer accurately measure oxygen levels, leading to incorrect input to the PCM. Additionally, wiring issues or shorts within the sensor circuit can disrupt the communication between the sensor and the PCM, again, resulting in abnormal readings. It is also possible for the PCM itself to develop faults that would erroneously interpret the sensor's normal output as a problem, thus storing the DTC. Each of these potential causes needs to be thoroughly examined as part of the diagnostic process to isolate the exact issue with the AF sensor system. Detailed examination of wiring integrity is also critical, as external damage could lead to intermittent failures that trigger this DTC. Symptoms associated with the DTC P0130-99 typically include poor engine performance, manifested as a lack of power or hesitation during acceleration. The vehicle may exhibit rough idling or stalling under certain conditions, particularly during deceleration, when accurate sensor readings are crucial. Additionally, increased exhaust emissions are a significant concern, as the incorrect air-fuel mixture can result in higher pollutants being emitted, potentially leading to failure of emissions testing. The check engine light will also illuminate on the dashboard, providing an early warning to the driver that a diagnostic trouble code is present. If left unaddressed, these symptoms can lead to more serious mechanical issues and reduced fuel efficiency, making prompt diagnosis and repair imperative for the vehicle's overall health. The initial troubleshooting step for DTC P0130-99 involves starting the engine and then holding the engine speed at 3,000 RPM without any load, meaning the vehicle should be in park or neutral. This step is crucial as it allows the engine to operate under specific conditions that help in evaluating the performance of the AF sensor. While maintaining this RPM, the vehicle's radiator fan will engage to cool the system, which is an expected behavior. It's essential to ensure that the system reaches a proper operating temperature. If the ECT sensor reading does not show above 158 degrees Fahrenheit, 70 degrees Celsius, further diagnostics may be needed. The goal here is to simulate a controlled condition under which the AF sensor can be further tested in the upcoming steps. Monitoring during this step sets a baseline from which any deviations can be noted and investigated in subsequent troubleshooting. In the second troubleshooting step, you will need to test drive the vehicle under specific conditions following the initial engine operation. It is crucial that the engine coolant temperature, as monitored by the engine coolant temperature ECT sensor 1, exceeds 158 degrees Fahrenheit, 70 degrees Celsius during this drive. Additionally, the transmission must be in drive, and the vehicle speed should be maintained between 25 to 55 miles per hour, 40 to 90 kilometers per hour, for at least 5 minutes for effective data collection. Following this, a consistent speed between 55 to 75 miles per hour, 90 to 120 kilometers per hour, for a duration of 10 seconds is necessary, after which you should completely close the throttle and decelerate for 5 seconds or longer. These specific conditions allow for a comprehensive evaluation of the AF sensor's response and performance during different operational states, creating an environment to capture any anomalies. The final step in the troubleshooting process involves monitoring the Honda Diagnostic System, HDS, for any recorded diagnostic trouble codes, specifically looking for the DTC P0130-99 or P2A00. The HDS allows technicians to access the onboard diagnostics (OBD) status of the powertrain control module, providing critical information regarding the operational state of the AF sensor, along with other related components. If the DTC returns, it verifies that an error is still present, leading to the conclusion that either the AF sensor requires replacement or further inspection of wiring and connections is necessary. Additionally, an understanding of the data list will provide insights into the current values and conditions that the ECT sensor 1 and other components are reporting at the time of the test. This step confirms whether the initial cause of the issue is resolved or if further action is required to ensure optimal vehicle performance. Following the successful completion of any repairs, a crucial final repair verification step is essential to ensure that the issue linked to the DTC P0130-99 has indeed been resolved. This process involves reviewing the vehicle's performance against the expected outcomes. The technician should initiate a retest using the Honda Diagnostic System, HDS, allowing for monitoring of the AF sensor and observing whether the previous fault codes return. Additionally, performing a road test under the specified conditions previously established can confirm that the sensor and related systems are operating correctly. Each component should respond within normal operating parameters, and there should be no illumination of the check engine light. Verifying that the AF mixture is being accurately adjusted will ensure the vehicle functions optimally and meets emission standards, solidifying the repair's integrity. To prevent future occurrences of DTC P0130-99, it is advisable to implement preventive maintenance measures focusing largely on the air-fuel ratio sensor and its associated components. Regular checks on the sensor performance can catch any early signs of degradation or failure, ensuring that the vehicle's engine management system operates efficiently. Additionally, routine monitoring of engine performance can provide immediate insights into irregular behavior that may signal potential issues with the AF sensor or its circuit. Maintaining clean connections and inspecting wiring leading to the sensor for any signs of wear or corrosion will contribute to long-term reliability. Furthermore, ensuring that the engine operates within temperature and load specifications supports the functionality of vital components. Following the manufacturer's service recommendations for inspections will play a significant role in mitigating unexpected repairs and maintaining vehicle performance. In summary, addressing the DTC P0130-99 involves a systematic approach to identifying and resolving issues related to the air-fuel ratio sensor. Sensor function is pivotal not only for improved vehicle performance, but also for compliance with environmental regulations on emissions. Each step outlined in the troubleshooting guide aims to methodically isolate causes, confirming whether the AF sensor is functioning correctly or if further issues exist within the wiring or PCM. The insights gathered from monitoring the HDS and implementing final verification tests are essential to ensure that repairs are effective. Following a regimen of preventive maintenance also helps in prolonging sensor life and maintaining optimal vehicle operation. Proper adherence to these guidelines will ultimately ensure a reliable and efficient driving experience with your 2023 Honda CR-V. Please like and subscribe to the channel. See you next time.